Hi dear students, today in this video I am going to discuss the remaining part of the chapter atoms and molecules. In this video, three main topics, one is molecular mass, formula unit mass and mole concept. First I am going to start with the molecular mass. The molecular mass of the substance is the sum of atomic masses of all the atoms in a molecule of the substance, and it is expressed in the atomic mass unit. That means how to calculate the molecular mass of a molecule. Simply, molecular mass is the mass of a molecule. It is the sum of the masses of all the atoms present in that substance or the molecule. Let's take two examples. First one is molecular mass of CO2, carbon dioxide. How to calculate the molecular mass of carbon dioxide? That is very simple. How many carbon atoms are there? One carbon atom here. So, atomic mass of carbon is 12. Plus, how many oxygen atom is here? 2. 2 oxygen atom. So, 2 into what is the atomic mass of oxygen? That is 16. So, 12 plus 2 into 16 is equal to 32. 12 plus 32 is equal to 44. So this is the molecular mass of CO2 molecule. Next, let's take one more example. Molecular mass of CH3OH. So in this case, how to calculate the molecular mass? See, what is the atomic mass of carbon? Atomic mass of carbon is equal to 12 plus how many hydrogen atom is here? 3 hydrogen here and 1 more hydrogen. So there are total 4 hydrogen atoms. So 4 into what is the atomic mass of hydrogen? 1 plus the atomic mass of oxygen is 16. So 12 plus 4 into 1 is 4. So 16. 16 plus 16 is equal to 32. So this is all about the molecular mass. How to calculate the molecular mass? Just find the sum of atomic masses of all the atoms present in that molecule. Clear? Next topic is the formula unit mass. Formula unit mass of a substance is the sum of atomic masses of all the atoms in the formula unit of a compound. And use the formula of unit for the substance whose constituent particles are ions. That is the difference between formula unit mass and molecular mass. We use the term molecular mass in case of normal compounds, while in case of ionic compounds, which means the compound formed by the ions, we will use the term formula unit mass. Clear? That is the difference. And the calculation of finding the formula unit mass is same as the calculation of finding the molecular mass. Let's take an example, that is NaCl. The formula unit mass of NaCl, formula unit mass of NaCl equal to, what is the atomic mass of sodium? Atomic mass of sodium is 23 plus what is the atomic mass of chlorine? That is 35.5, which is equal to 58.5 U. So why we use this term formula unit mass in case of sodium chloride? Because sodium chloride is an ionic compound which consists of sodium ions and chlorine ions. That is, cation is sodium and anion is chlorine. Clear? Why this specific term is required? Let's examine that one. See here, you can see carbon dioxide. One carbon and 2 oxygen. In case of carbon dioxide, you can see in this video, that is, each carbon dioxide molecules are independent. That is a single entity exists in case of carbon dioxide gas. Clear? So we will use the term molecular mass. Molecular mass. Well, in case of sodium chloride, this representing sodium chloride. In case of sodium chloride, you can see that one sodium and one chlorine atom form sodium chloride molecule. At the same time, the same sodium atom is linking with another chlorine to form another sodium chloride. That means a single entity is not existing. These all atoms are interconnected each other. So we cannot say that a molecular mass instead of that formula unit mass, because the formula of sodium chloride will be NaCl, one sodium and one chlorine. The ratio of sodium and chlorine will be 1:1. After every sodium, another is chlorine. The next is sodium, the next is chlorine. It is like that. So the ratio is 1:1. Because of that, we will call formula unit. Clear. So the mass of this will be formula unit mass instead of molecular mass. So this is the difference between, so we will use the term formula unit mass. So this is the difference between molecular mass and formula unit mass. Okay. Calculation method of calculating are same, but the term formula unit mass we use in case of ionic compounds. Okay. That's all. Next topic is that mole concept. That is very important concept, because we know that even if you take a small cube, a metallic cube with a side 1 centimeter, it consists of millions or billions of trillions of atoms or particles. Because of this reason, it is not easy to represent the number of particles in a small range. We need a particular number to represent. We cannot represent in thousands or lakhs or billions, because it is beyond that. So there is one particular number to represent the number of particles in particular amount. That is the number of particles, whether it can be atoms, molecules or ions, present in 1 mole of substance is fixed with a value of 6.022 into 10 raised to 23. Like 1 dozen, we say that 1 dozen is equal to 12. That is 1 dozen chocolate is equal to 12 chocolates. 2 dozen chocolate is equal to 2 into 12 chocolates. That is 24 chocolates. Similarly, 1 mole of particles, 1 mole of anything will be is equal to 6.022 into 10 raised to 23 in number. That is, we can say that 1 mole atom, 1 mole of atoms is equal to 6.022 into 10 raised to 23 atoms, or 1 mole of molecules is equal to 6.022 into 10 raised to 23 molecules, or 1 mole of ions is equal to 6.022 into 10 raised to 23 ions. That means 1 mole of anything, that is equal to 6.022 into 10 raised to 23 in number. Clear? Why we use a particular number like 6.022 into 10 raised to 23 instead of like simple 10 raised to 23 or 10 raised to 24? We will get a clear idea why we are using this number while we are discussing the molar mass. Clear? Then what is molar mass? The molar mass is the mass of a 1 mole of substance, and it is very easy to find the molar mass of a molecule or atoms. It is the mass of 1 mole of a substance is equal to its relative atomic or molecular mass in grams. Very simple. This is the reason why we use 6.022 into 10 raised to 23 number of particles as 1 mole instead of a simple value like 10 raised to 23. 1 mole is equal to 10 raised to 23 or 10 raised to 24. Because to get molar mass, that means, for example, we can say that atomic mass of oxygen atom is equal to 16U. So molar mass of oxygen atom will be, molar mass of oxygen atoms atoms is equal to 16 gram. Very simple. That is, mass of one oxygen atom is equal to 16 U. Just to convert that number into gram or represent in gram, we will get the molar mass of oxygen atom or mass of 1 mole of oxygen atom. Clear? If you take any other number like 1 mole is equal to 10 raised to 10 or 10 raised to 24, then mass of 1 mole or molar mass of that particular substance will not be equal to the numerical value represented in the gram. Clear? Because of this reason, we taken the value 1 mole is equal to 6.02 to 10 raised to 23. It is experimentally proved. And the number 6.02 to 10 raised to 23 is known as Avogadro number. Avogadro number. Avogadro is a scientist who given the concept of number. Okay. Let's take another example. One more example we can take, that is, okay, regarding the molar mass. I am going to take one more example, that is molecular mass of H2O is equal to, what is the mass of hydrogen? 1. So 2 hydrogen are there, 2 into 1, plus what is the mass of oxygen? 16, which is equal to 2 into 1, 2, plus 16 is 18. So the molar mass of H2O will be, molar mass of H2O is equal to 18 gram. Whether it is atoms or ions or molecules, whatever it is, the molar mass will be the value with just representing atomic or molecular mass in gram. Clear? So this is the way we can find molar mass. So here you can see very clearly that one is 1 mole of carbon atom is equal to 6.02 to 10 raised to 23 atoms of carbon, and that is equal to 12 gram of carbon atoms, which is the molar mass of carbon atoms. Similarly, 1 mole of hydrogen atom will be 6.02 to 10 raised to 23 atoms of hydrogen, and that is equal to 1 gram of hydrogen atom, which is the atomic mass. 1 U is the atomic mass and 1 gram is the molar mass. Similarly, 1 mole of any particle or molecules, 6.02 to 10 raised to 23 number of that particles, and relative mass of those particles in the grams. That will be the molar mass. So this is number of particles and this is the molar mass. Clear? And 1 mole of molecules will be 6.02 to 10 raised to 23 number of molecules, not the atoms. Similarly, molecular mass in grams, that is molar mass of that molecule. Okay. Now discuss some mathematical formulas that we have to use to solve the problems which involve mole concept. That number of moles, we can write it as number of moles is equal to given mass divided by molar mass. For example, molar mass of water molecule H2O is 18 gram. That means 1 mole of H2O is equal to 18 gram. Then what is the mass of 2 moles of H2O will be is equal to 2 into 18, which is equal to 36. That will be the given mass. So the number of moles is equal to given mass divided by molar mass. We will get how many moles are there. Second, one more relation. This is in case of mass. One more relation we can write, that is number of moles is equal to given number of particles divided by Avogadro number. Avogadro number. Why? Because in 1 mole 6.02 to 10 raised to 23 particles. Then in 2 moles 2 into 6.022. That will be the given number of particles. So to get the number of moles, we divide the given number of particles divided by Avogadro number. This formula we will use in terms of if the question involves number of particles. This formula we will use question involve mass of the substance. Now we can simplify like this. Given mass we can represent it by small letter m and molar mass represented by capital M. Similarly, the given number of particles we can represent at capital N and Avogadro number we can represent it by N0. And LHS of both equations are equal. So obviously RHS also equal. So we can equate like M divided by capital M is equal to N by N0. So it is very important to remember this formula if the question involves both the number of particles as well as mass. Clear? So very important formula we have to remember. M by N, small letter m divided by capital M is equal to capital N divided by capital N0. Where small letter m is the given mass, capital N is the molar mass, capital N is the now given number of particles, and N0 is the Avogadro number. Let's take some questions to understand this formula, that is convert into mole 12 gram of oxygen gas. Exercise question number 8 option A. So here you can see 12 grams. So given mass is equal to 12 gram. Okay. And molar mass of oxygen gas. Molar mass of oxygen gas. Oxygen gas means it is exists in the state of O2. That is very important. Okay, we are not supposed to calculate the molar mass of oxygen atom. We are supposed to calculate the molar mass of O2, that is oxygen molecule, because the oxygen gas exists as O2 molecules. Clear? So that is equal to 2 into what is the atomic mass of 2 oxygens are there. So 2 into what is the atomic mass of oxygen? 16. So 2 into 16 is equal to 32 and gram. So this is the molar mass. The number of moles convert into mole. That means the number of moles is equal to number of moles. Number of moles we will represent in terms of small letter m. Okay, that is equal to given mass divided by capital molar mass, because here the question involved with the mass of the substance. So given mass is 12 divided by molar mass is equal to 32. Simplifying this 12 divided by 32, what will we get here? 3 divided by 8. Am I right? 3 into 4 is 12. 8 into 4 is 32. 3 by 8 is equal to, just represent this fraction in decimal form. So we will get 0.375. Clear? So this is about. Let's take one more example, that. Example 2. Convert 12.044 into 10 raised to 23 molecules of water into mole. So here you can see the given number of particles, that is N, is equal to 12.044 into 10 raised to 23. What is the Avogadro number? Avogadro number is equal to, what is the Avogadro number? N0 is 6.022 into 10 raised to 23. Clear? So the number of moles will be is equal to N. Number of moles will be given number of particles divided by Avogadro number, which is equal to 12.044 into 10 raised to 23 divided by 6.022 into 10 raised to 23. So divided, what will you get? 10 raised to 23 divided by 10 raised to 23 is cancelled. 12.044 divided by 6.022 is equal to 2. Just try your calculation by yourself. Okay, so 2. So this formula we use if the question involves number of particles, and we will use this formula if the question involves mass of the substance, and we will use this one if question involves both number of particles as well as mass of the substance. Clear? If you know this concept, it's very easy to understand mole. So next one is the mole concept in chemical reaction. How a mole concept comes in chemical reaction? Mole concept in chemical reaction. In chemical reaction. See, for example, I am writing that is 2H2 plus O2 is equal to 2H2O. This is the balanced chemical equation because the left side as well as right side of this equation consists of same number of particles of each kind. Because here 2H2, that means 4 hydrogen atoms is there. Here also 2H2, 4 hydrogen atoms. Here O2, 2 hydrogen atoms there, and here also 2 into O2, 2 into O, that is 2 oxygen atoms. Okay, what are the informations we will get from this equation? That is two molecules of hydrogen react with one molecule of oxygen to get 2 molecules of water. 2 molecules of water. Similarly, one more information that we will get. 2 molecules of H2 means there are 4 hydrogen. That means 4 into 1, that is 4U. So 4U hydrogen atom, that is atomic mass, total atomic mass of all these 4 hydrogen is equal to 4. So 4U hydrogen react with how many oxygen is there? 2 oxygen, that is 32. 2 into 16 is 32. So 32 oxygen to get 4 hydrogen is there here. Okay, so that in the right side 4 hydrogen is there, that is 4U plus 2 oxygen is there, that is 32. So 4 plus 32 is 36U of water molecule. That is the third information we get, that is very important. Here 2 molecules of hydrogen react with 1 molecule of oxygen. Similarly, we can say that the 2 moles of H2, okay, react with 1, because only here O2, that means 1 into O2. So here it is 1 actually, 1 into O2. Clear? So 1 mole of O2 to get how many molecules of water is there here? 2 molecules of water. That means 2 moles of water. These are the informations we will get regarding the moles, number of moles from a chemical equations. Okay. So the theory part is over. Now I am going to discuss some in-text question as well as some exercise questions. Okay. First one I am taking in-text question from page number 42. That is, if 1 mole of carbon atom weighs 12 grams, what is the mass in grams of 1 atom of carbon? According to the question number 1, 1 mole of carbon atom weighs 12 grams. Am I right? 1 mole of carbon atom, 1 mole of carbon atom weighs 12 grams. That means mass of 6.022 into 10 raised to 23 carbon atoms. The atoms is there. Okay? Carbon atoms is equal to 12 grams. Because 1 mole of carbon atoms is equal to 12 grams. Sorry, mass of 1 mole of carbon atom is equal to 12 grams, which means mass of 6.022 into 10 raised to 23 carbon atom. Because 1 mole of atoms is equal to 6.022 into 10 raised to 23. Therefore, mass of 1 carbon atom is equal to 1 carbon atom is equal to Mass of 1 mole of carbon atom, that is 12 divided by number of particles, that is 6.022 into 10 raised to 23. Okay. Very simple one. Mass of 6.022 into 10 raised to 23 carbon atoms is equal to 12 gram, which means mass of one carbon atom will be 12 divided by 6.022 into 10 raised to 23. That is equal to, you try the calculation yourself, I am not going to do that one. 1.9 into 10 raised to minus 23 gram. Let's take one more question that is from the same page, that is question number 2. Which has more number of atoms, 100 grams of sodium or 100 grams of iron? So here number of atoms we have to find it and mass is given. So we know that the formula we are going to use here, because we have to find number of atoms but mass is given. So we have to use the formula, that one is N by N0 is equal to M divided by capital M. This formula we have to use because it involves both the number of particles and the mass of the substance. In first case, sodium. In case of sodium, we are going to calculate. In case of sodium, that number of particles we have to find. So we can rearrange this formula, that N0 we can take to right side. So it will be M divided by capital M into N0. Clear? Now M by, what is the given mass of sodium, that is 100 gram. Clear? So 100 divided, what is the molar mass of sodium? Atomic mass of sodium is equal to 23. So molar mass will be 23 gram. Clear? Into N0, which is equal to 100 divided by 23 is equal to 4.34 into N0. Clear? Similarly, next we can take that one is iron. Okay, iron we are going to take. So in this case, N is equal to given mass divided by molar mass into N0. We modify this formula. Okay, nothing to do with it. Now given mass of iron is also 100 gram. Clear? So 100 gram divided by, what is the molar mass of iron? What is the atomic mass of iron? That is equal to 56. So molar mass will be 56 gram. Clear? So into N0. 100 by 56 is equal to 1.78 into N0. So which one will be greater? Which one will have more number of particles? 4.34 into 6.02 into 10 raised to 8 is greater than 1.78 into 10 raised to, sorry, 60 into 6.02 into 10 raised to 23. We don't need to express this number actually, because this N0 is same for both. Let's take some exercise questions to discuss that one. First question I am taking, that is question number 1. Okay, a 24 gram sample of compound of oxygen and boron was found by the analysis to contain 0.096 gram boron and 0.144 gram of oxygen. Calculate the percentage composition of the compound by weight. So very simple one, that is percentage of boron is equal to what is the mass of the boron? That is 0.096 divided by what is the mass of whole substance, that is whole quantity is 0.24. So 0.24 into 100. Very simple percentage concept. The given particular quantity divided by the whole quantity into 100. That's all. So 0.096 divided by 0.24 is equal to 0.4 into 100. 100 is here. So 0.4, which is equal to 40. 0.4 into 100 is equal to 40. So 40%. Very simple. Numerical calculation I am not going to explain here. You are a classman, so you are able to do that one. Okay. So we don't have much time to discuss that one also. Next, percentage of oxygen, similarly we can find percentage of oxygen. Very simple. What is the mass of the oxygen? 0.144. Divided by what is the mass of coal? 0.24. So 0.24 into 100. Simplify these calculations, you will get here 60. So 60%. So this sample consists of 60% oxygen and 40% boron. Okay. Next, question number 5. Some questions I am leaving here because I already explained in detail how to find the molecular this chemical formula and all the things, so that you can try yourself. I am taking question number 5. The first one, the question number 5 I am taking. Give the names of the elements present in the following compounds. Very simple one. First one is quicklime. The chemical formula of quicklime, that is calcium oxide. Calcium oxide. That is CaO. So what are the elements present in here? Calcium and oxygen. These are the elements present in compound. Second one is that option B, that is hydrogen bromide. Very simple one. What are the compounds present in the hydrogen bromide? That is because the chemical formula is HBr. Hydrogen bromide. So the elements present in this hydrogen bromides are hydrogen and bromine. Clear? Okay. The third one is that baking powder. The chemical formula of baking powder is sodium bicarbonate or sodium. If bicarbonate, we will write it as hydrogen carbonate. Hydrogen carbonate. So, what is sodium? The chemical formula will be Na. We have already discussed the symbol of hydrogen carbonate in the last section, that is HCO3. So, hydrogen carbonate is also named as bicarbonate. Remember that. So, what are the elements present in here? First one is sodium. Okay, sodium. Second one is hydrogen. And third one is carbon. Carbon. And fourth one is oxygen. These are the elements. The same formula we will use in case of baking soda also. Baking soda. The small differences in the chemical composition, but still major component of baking powder and baking soda are same. While washing soda is different. The chemical formula of washing soda is actually sodium carbonate. A small difference. First one is sodium bicarbonate. Baking powder is sodium bicarbonate, while washing soda is sodium carbonate. The chemical formula will be Na2CO3. So it is very important to remember, not to confuse about it. Okay, if you write only sodium carbonate, that will not be baking powder, that will be washing powder, also washing soda. Okay. So next, last topic, the option is potassium sulfate. That is very simple one. Option D, potassium sulfate. Potassium is K and sulfate. So K2SO4. You can write the chemical formula by yourself. So what are the elements here? First one is potassium. Second one is sulfur and oxygen. These are sulfate means never write only sulfur, okay, because sulfate consists of sulfur as well as oxygen. Clear? So this is all about question number 5. Next question is convert into mole. Say similar question, we already discussed that one. 20 gram of water into mole. Very simple. Question number 8, option number B. So here number of moles we have to find, that is small letter n, which is equal to mass is given. That means given mass divided by molar mass formula we can use. What is the given mass? 20 divided by molar mass is equal to, what is the molar mass of water? 18. We already discussed in the previous question, so I am not going to repeat that one. Okay, 20 divided by 18, we can simplify, that is 10 divided by 9. 10 divided by 9 is equal to 1.11, etc. It is has no terminating repeating decimal expansion, so 1.11, that is enough. I just write two decimal number. Just write two numbers after the decimal point. Okay. So this is the answer. So next question is question number 9. What is the mass of 0.2 mole of oxygen atom? Very simple one. Because we already know the formula. So just apply that one. 2 mole. Number of moles is equal to 0.2. Okay. And oxygen atom. So mass we have to find it. So molar mass of oxygen atom is equal to 16, because atomic mass of oxygen atom is 16. So the molar mass of oxygen atom will be 16 gram. The given mass we have to find it. So what is the basic formula we have? N is equal to m divided by capital M. Okay. So just to take this capital M to here. So we modify this formula, we will get that implies m, small letter m, is equal to n into capital N. Clear? So just substitute the values. 0.2 into, what is the molar mass of oxygen? That is 16. 2 into 16 is 32. 1 decimal is 3.2. And the last question I am going to discuss, that one is calculate the number of ions present in 0.051 gram of aluminium oxide. So first one is that given mass is equal to 0.051 gram. Molar mass we have to find it. So the molar mass of aluminium oxide, chemical formula is Al2O3. That is a chemical formula of aluminium oxide. Clear? Which is equal to, how many aluminiums are there? 2 into atomic mass of aluminium is 27. So 2 into 27 plus how many oxygen is there? 3 oxygen. So 3 into, what is the atomic mass of oxygen? 16. 2 into 27 is 54 plus 3 into 16 is equal to 48. So 54 plus 48 is equal to 98 to 102 gram. This is the molar mass. Now number of ions we have to find it. First let's find the number of molecules of aluminium oxide present in this. So number of molecules of aluminium oxide Al2O3 is equal to small letter m divided by capital M into N0. This is the number of molecules. That means number of particles, which is equal to m is given mass is 0.051 divided by m is equal to capital N is 102 into N0. Just to keep as it is N0. Okay. No need to multiply right now. That is equal to, just to simplify, 0.051 we can write it as 51 into 10 raised to minus 3. Am I right? We will get a, okay, 3 decimal places. So we will get a 51. So 51 into 10 raised to minus 3. Okay. Divided by 102 into N0. Which is equal to 51 divided by 102. We will get a 1 by 2. Into 10 raised to minus 3 into 0. Clear? Now this is, we have got only the number of aluminium oxide molecules, but in one aluminium oxide molecule there are 2 aluminium ions present, because mass of the ion and aluminium ion and mass of the aluminium atom same. Clear? Because the mass of electron is negligible. So here in one molecule of aluminium oxide, there are 2 aluminium ions present. Okay. So therefore, number of Aluminium ions is equal to 2 into 1 by 2 into 10 raised to minus 3 into and now we substitute the value for 0, that is 6.022 into 10 raised to 23, which is equal to 2 into 1 by 2 cancel, clear, 6.022 into 10 raised to 23 into 10 raised to minus 3, which is equal to 6.022 into 10 raised to 23 and minus 3, that will be 20. Clear? A raised to m into a raised to n is equal to a raised to m plus 23 plus minus 3 will be 20. While you are solving the question, first find the number of molecules according to the question. Because here given mass is relating with aluminium oxide. So first find the number of molecules or particles in the particles of aluminium oxide, which means the number of molecules of aluminium oxide. Then count the number of that particular atom which is asked in the question in one molecule of that substance. Then multiply with that. Clear? So we will get the final answer. So according to the question, we have to give the answer. So this is all about this today's class, and we have completed this chapter, atoms and molecules. Try maximum different type of questions by yourself so that you will get a clear idea about the mole concept. Okay, so I'm going to conclude this chapter with this video, and in the next video I will come up with the structure of atom. So that's all for today. Thanks for watching.